This video introduces you to the concept of random variables, variation, and sampling. They say a statistician is someone who can have their head in the oven and feet in ice, and on average, they're comfortable. However, the key to statistics is not simply to consider averages, but to understand variation. We better understand variation by sampling. Variation is all around us. Consider the bottles of 600ml Coke you buy. The variation may be small, but some will be a little fuller than others. Consider the lifetimes of a particular brand of lithium battery, or a light globe, or the composition and taste of two pizzas of the same type bought from the same location, or the pull-off force of connector rods in an engine. In each scenario, the items are constructed the same way from the same set of ingredients. However, the end result varies. The amount of variation is important to quantify and minimise. Whether it is volume in a bottle, battery lifetimes, or connector rod strength, the amount or size of each of these measures will vary depending upon which bottle, battery, or connector rod we happen to observe. Consider testing 3 batteries to exhaustion to measure their lifetimes. With a precise enough measuring instrument, we will always identify varying times to failure. Since the lifetimes, measured in hours for example, exhibit variability, we consider battery lifetime, which is our measure of interest, to be a random variable. Using notation, the random variable, denoted by x, may be considered as assuming values according to the following model. X equals mu plus E, where mu is a constant and E is a random disturbance. So what does this mean? The constant, as the name suggests, remains the same with every measurement. However, small changes in the manufacturing process, the environment, test equipment, etc. result in varying values for E and hence varying values for X, which is the real capacity of the battery. As we consider more and more batteries, we build up a picture of how the variable is distributed. We can now see how there is variability in X. We often need to describe, quantify, and ultimately reduce variability. However, we know that we cannot test all batteries to exhaustion, else there would be none to sell. We wish to have an understanding of the variable, lifetime, including the size of variation without testing all items. This is where sampling comes into use. Sampling is the process of taking a subset of items from a larger group, which is referred to as a population, in order to infer about said population. There are many aspects of sampling that need to be considered, but that will have to be left to another day.